welcome to our video.
You want to see us bowling? Continue watching.
As you can see, the first topic we're going to be talking about is applied force.
An applied force is a force that is applied to an object by a person or another object.
To find the amount of applied force, you multiply the mass of the ball by the acceleration. The mass of our ball is 3.6 kilograms. The acceleration is 1.5 meters per second. So then you would multiply these two together and you get 5.4 newtons.
The reason we found the applied force was because this determines the velocity of the ball and how much force the pins would receive in order to fall. Next we have velocity. Velocity is the speed of something in a given direction.
Another thing we can find is the velocity of the ball. To find velocity, you divide the distance of the alley by the amount of time it took the ball to hit the pins. The distance of the alley is 18.29 meters, and the time is 3.5 seconds. Once you divide them together, you get a velocity of 5.2 meters per second. Momentum has a big role in bowling as well. When a small ball hits the pins, hardly any of the pins get knocked over. On the other hand, a heavier ball has enough momentum to knock down all of the pins as a result of collisions with the ball and the pin. Next, we will be looking at momentum. Momentum is the quantity of motion of a moving body, measured as a product of its mass and velocity. So, here we have the conservation of momentum. And pretty much what the conservation of momentum is, as the ball is rolling down the alley, that is the first part of the momentum. And as it's hitting the pins, the energy is then transferred to the pins that have fallen. And that is where we get our equation of conservation of momentum. So, it would be the first mass multiplied by the first velocity plus the second mass, which would, the first mass would be multiplied by the second velocity. And here is where it is conserved to the pins. So then you would multiply the first mass times the final velocity instead of initial, the first, and then multiplied by the second mass and the second final velocity of the second object.
After you find the conservation of momentum, you can then determine that as long as objects are moving, they will always be in motion. And since they're in motion, they will have momentum. The next topic we will be talking about is kinetic energy. The equation for kinetic energy is 1/2 mv squared, where m equals mass and v equals velocity. For kinetic energy to occur, there needs to be a velocity greater than 0. Kinetic energy increases proportionally with mass. Kinetic energy also increases proportionally with the square of velocity. The greater the mass and velocity of a bowling ball has, more kinetic.
To find velocity, we would have to multiply 1/2 times mass and velocity. Our mass is 3.6 kilograms. Our velocity is 5.2 meters per second. When you multiply 1/2 times mass and velocity squared, you get 9.36 joules. As you can see, bowling isn't as simple as rolling up the ball and hitting the pins. It involves mathematical equations that you can solve just by having the distance, time, and the mass of the objects. This information can be very useful when thinking more into depth about your game. By all counts, and with proven results, this is the physics of bowling. You can find momentum, velocity, kinetic energy, and so much more if you really think about it.